Okay, so for this one, we are going to complete the table, and our function is f of x equals 3 to the x. We also have g of x equals 5 to the x, and we're going to graph both of these on the coordinate axes that you see there. So one thing to consider is what x values are helpful to evaluate, and we often want to include the y-intercept in there somewhere in the middle. So supposing we make sure we include 0 and a couple of values to the left, a few values to the right, and they may not all make it on my graph, but it'll give me a nice set of points. So I'm going to write what I'm going to evaluate below each of these, and then we'll talk about what each of these is equal to. Some of these are easier than others. So 3 to the 1 is 3 times itself 1 times, 3 squared is 3 times itself 2 times, etc. So these are a little bit easier usually. Remember that anything to the 0 power is simply equal to 1. And if we take something to a negative power, it puts it in the denominator and keeps the power with it. So this is actually 1 over 3 to the 1. It's just that 3 to the 1 is equal to 3. Similarly here, this is 1 over 3 to the positive 2, which becomes 1/9. And you can envision that as we go into bigger and bigger negative numbers, those numbers are going to end up having bigger and bigger denominators. In other words, they're going to get close to 0. So we do have a horizontal asymptote when it comes to the exponential functions. So let's plot these points. We're going to use blue for f of x. And I'm going to plug in 0, 1, 1, 3, 2, 9, 3, 27, which will be way up there. And then negative 1, 1/3, negative 2, 1/9, and so on. And we'll just make it clear that this is going to be a horizontal asymptote. And this is going to spike up. Now, unfortunately, I'm making this video during the coronavirus epidemic, and this is the kind of growth that we see when it comes to this virus. So, hopefully I'll be able to come back and go through some of what's going on with some data that's going on currently in the world. But one of the reasons that we're all at home right now is actually because we don't want to create this giant spike that you're seeing here, because notice how the growth pattern isn't steady. It's like it goes up by, multiplying by 3s, which is not exactly the same pattern that we're seeing in this virus, but it is also a multiplying pattern. So, multiplying by 3 only gets it 2 bigger at first, but then it gets it 6 bigger, and then it gets it, 18 bigger, and it continues to just spike, spike, spike until it reaches a dramatic height. So this is really exponential growth that we're dealing with right now. All right, similarly here, this time, every single time we're multiplying by 5 to grow, but you can simply go through and plot the values to do this. You don't have to think about what are you multiplying by. You can input the values to the function. So we're going to use the same ones here. And you'll notice that we really don't go up high enough on our graph to do that, that 3. So we have 5 to the negative 2, 5 to the negative 1, 5 to the 0, 5 to the 1, 5 to the 2, and 5 to the 3. And when we simplify these, we have 1 over 5 squared, which is 1/25, which is very close to 0. 1 over 5 to the 1, which is just 1 over 5. 5 to the 0 is 1. And then 5 to the 1, 5 to the second power is 25. And 5 to the third power is 1/25. So we can see the spiking pattern is already beginning when it comes here, to the point where we really aren't even getting it on this little graph right here. So if we want to go back and graph these points, notice they're both crossing in this same place right here, and yet the other points don't line up. So when we're at 1, we're up at 5. 2 is way up here at 25, way off the screen. So this spikes up more steeply. Negative 1 is 1/5, which would be below 1/3. and similarly here. So they both are going to approach the 0, but this one's going to approach the 0 a little bit more quickly. Now for both of these, I want to point out that this right here, this is called the base of the exponential function, and for both of those, the base is a number that's greater than 1. So when the base is greater than 1, this is what it looks like. Because when the base is greater than 1, then when we multiply, it's going to make it grow. It's going to make it get bigger because we're multiplying by 3. Multiplying by 3 makes it bigger. Multiplying by 5 makes it bigger. However, if you take a look at this right here, that's no longer going to be the case. We're going to notice that we're multiplying by 1/2 in this case, or we're multiplying by 1/3, and that's going to make it get smaller. So let's take a look at what that looks like. And we're still going to use a lot of the same numbers. This time you'll see I go a little farther on the left. So I'm going to actually have still a few numbers around 0, but I like to have my extra on the left, and you'll see why in a second. Same thing here. And let's evaluate each of these. So this is 1/2 to the -3rd, or we could use the 2 to the negative input. Either way, regardless of which one you use, you're going to see that this turns into 2 to the 3rd power. So let's talk about why that is. 1/2 to the -3, that negative outside in the exponent is going to reverse which is in the numerator and which is in the denominator. So this now will become 2 to the 3rd. You may find it easier to work from this one, but you should be able to work from either one. I don't know why I made that into a 4. Here we go. 2 to the 2. So we end up with 8, 4, and again on this one you can plug it into either one. You can plug it into 1/2 to the x, or you can plug it into 2 to the negative input. And either way, we're going to end up with 2 to the 1 power. So for 2 to the 1 power, that gives me a 2. These other guys are a little bit easier done with the 1/2 to the x. And we end up with 1, 1/2, and 1/4. So it's a very similar pattern, but the negative numbers are now where it's spiking, and the positive numbers are where it's going off toward the horizontal asymptote. So let's get a little graph of that going. I'm going to graph h of x first. So that's -3 is up at 8, -2 is at 4, -1 is at 2, 0, 1, 1, 1/2, and then 2, 1/4. And so we have our, this is really an exponential decay model. And if we now switch to r of x, it's going to be really the same kind of thing. We can either use 3 to the negative x, or we can use 1/3 to the x. And we get to sort of choose based on what's going to be easier to work with. On the first one, certainly it's easier to work with the 3 to the power, but you can do it either way. And so this becomes 3 to the 3rd, which is 27. That's going to be up off the chart. 3 to the 2nd, which is 9, and 3 to the 1, which is 3. Then we end up with 3 to the 0, or -0, or you could picture it as 1/3 to the 0. Either way, you get 1. And then I like to use the 1/3 for these, but truly you can use either one. So we have 1/3 and 1/9. And now let's graph that. We'll have -3 to the 27th is up off the chart. -2 to the 9th would be here. I'm sorry, negative 2 comma 9 would be there. Negative 1, 3 would be here. 0, 1 is where they cross. And then we have 1, 1/3, which will be just a little below the 1/2, and 2, 1/9, which will be below the 1/4. And we can draw this right here, which leads to the other exponential decay function. And so we'll see that this is when this is exponential decay. And this happens when we have a base that is between 0 and 1. In other words, if we call the base A, then A is greater than 0 and less than 1. Whereas if we look up at the top here, this one had a base that was greater than 1. So you can actually glance at the base for an exponent and just determine by glancing at the base, is this going to be exponential growth? Or is it going to be exponential decay? All right, so that's the end for this page right here. We're going to continue on and sort of generalize what are some properties of exponential growth and decay graphs.